Hi, my name is Martin of the Avisist Bird Box group. Last year, the Audubon Society published that two-thirds of the bird population will decline by 2100. This includes all species, including invasive species. This is due to habitat loss, deforestation, and predatory populations. Birds are crucial to an ecosystem, and it's essential to observe them and study in their natural habitats. And currently, data must be collected faster than the current time-consuming and invasive methods used.
Hi, my name is Alyssa Stover, and I'm a developer. Avisist is a three-part solution that was developed to utilize IoT technology in birdhouses to assist researchers studying the parental and nesting behavior of birds. Part one of the solution is the data collection, where sensors attached to the birdhouse continuously record bird behavior and reduce the need for physical and invasive data collection tactics that are used by researchers today. Part two involves Avisist software that stores and aggregates the data being collected in the field in an organized manner, making retrieval of this data much more efficient. And part three is the use of the Avisist website, which allows researchers to now use their collected data to run analytics and share their findings with others.
Hi, I'm Bana, the Scrum Master. Now that we've explained our problem and solution, I'm going to navigate through the website avisist.com as if I were a researcher conducting a study on eastern bluebirds. We first start on our Find a Birdhouse search tool. Now, depending on my needs as a researcher, I can type in the name of the species, the location I want to study it in, or the pollutant I want to learn more about. If I already have a kit, I can just type in the serial number to order the same one again. Once I hit search, I'll be led to a results page where I can see many different options depending on the criteria I entered in the last page. For the purposes of this example, like I said, we are going to be looking at the eastern bluebird. So once I click on that, I can find out more, including the difficulty level of the birdhouse kit and setup, and what's included in the kit, like cameras, thermometers, batteries. And if I wanted to, I can click Learn More and learn more about the technology that's included.
The birdhouse could be equipped with a motion sensor that interacts with noise sensors, weather sensors, megapixel cameras, or a load cell. I would need a load cell to conduct initial research because it can accurately measure the weight of the nest and the average weight of the eggs or hatchlings to compare against control enclosures so that I could draw faultless conclusions.
So after I finish purchasing and my kit has arrived, then I head to the dashboard, and here is a diagram highlighting the progression of steps of aggregating the kit and the dashboard. So how it would happen is a user joins a team and works on a project focused on a bird in a specific habitat, and that team then will collect data through a specific birdhouse or an array of birdhouses, all hooked up to a Raspberry Pi device that has sensors collecting bird data and sensors collecting habitat data. All that data that's collected is then sent to the project data set and the habitat data set.
After I have received my package, I head over to the user interface where I log in. I am taken to my user dashboard, where I am shown a quick overview of my active devices, projects, teams, and habitats. Notifications and recent user activity show me important information. House occupancy and compared to last week modules can be changed based on what I feel is most important. As a new user, I first need to create a new team and a new habitat. I am then ready to start my new project. I must fill out the form with details about the project, such as the name, description, and the focus of the project. I will now link the project to my team and habitat.
The second step of creating a new project involves having researchers input the variables, controls, and hypothesis of their potential research project. We learned having this step was very important to ensure the aspects of the study were thought through, as many researchers do not know these critical elements of their own study. This can lead to unnecessary observations, inaccurate conclusions, and loss of time and money.
After I receive my electronics package and assemble my smart birdhouse, I activate the device in the Activate Device tab. Before placing my device in the field, I make sure to thoroughly test my sensors. I want to check on a project that I've already started. Project Overview shows all of my active and past projects. I want to see more about this project. I click View Dashboard. The banner and navigation have changed to blue, showing me that I am inside a project. I can see the location, devices, and users linked to this project. Project Analytics shows me visuals based on the data my project has collected. Changing the view of a graph allows me to check different houses or view different variables. Each graph allows me to make notes or mark critical points as I conduct my research. I can view all of my observation records in the Project Records tab. Here I can see the media element captured by my smart birdhouse. A grid overlay allows me to measure these eggs. As a researcher, it is also important for me to understand what is going on in the birds I study's habitat. I can access the habitat analytics by selecting a habitat in the habitat overview. I can view all of my habitat and bird observation records in the All Records tab to quickly search and find a specific record.